Every body continues in a state of rest or of motion in a straight line at constant speed unless acting upon by a non-zero force, also known as Newton's first law. Newton's second law. The acceleration produced by net force on a body is directly proportional to the magnitude of the net force, is in the same direction as the net force, and inversely proportional to the mass of the body. Newton's third law. Whenever one body exerts a force on a second body, the second body exerts an equal and opposite force on the first. Newton's first law. Every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. Newton's second law. Force equals change of momentum with change of time. Force equals mass times acceleration. Force equals mass times change in velocity with time. Newton's second law. The heavier an object weighs, the more force it takes to accelerate it. Newton's third law. For every action there is an equal or opposite reaction. The rocket is pushed forward by the exhaust flow that is pushed backwards and is propelled upwards by the same force that exits the exhaust. This ball thing is a great example of Newton's third law because when you pull back two balls, the two balls that it hits are propelled with the same force that they hit. Newton's third law. For every action, there's a reaction. The water's calm and still, but when he jumps, the water moves out of his way. Newton's third law. For every action, there's a reaction. Notice when he kicks, the punching bag moves away. The action is kicking and the reaction is the punching bag moving away.
Most Greek scientists studied motion and divided it into two types, natural motion and violent motion. Natural motion on Earth was thought to be either straight up or straight down. For example of straight up or straight down, a puff of smoke would rise into the air.
Or a hill, so the ball is in equilibrium. No net force is acting on it.
But if the object suddenly began to move, you would look for forces that don't balance to zero. For the ball to have been moved, there had to be a force. The force that was put onto the ball was me kicking it. Aristotle, the foremost Greek scientist.